Today we are going to sort of bring it full circle and take our equations and go back to something that's pretty easy for us to graph. All right. So we're going to change an equation from standard form into vertex form. Standard form is good, it's basic, and it really only gives us one piece of information, and that is the C value is always the y-intercept. The y-intercept in this case over this line would be 0, 25. But if I can change it into the vertex form, I can find out some more information. The vertex form, of course, is y equals a times, and in parentheses, x minus h squared plus k. And in this case, if we can put it into the vertex form, we can pick out the numbers that are sitting where the h and the k are, and that's going to be my vertex. To do that, I am going to have to complete the square. Notice in this equation, y equals 2x squared minus 12x plus 25, I do not, and I'm not going to set it equal to 0 because I'm not trying to solve it. All right? I'm trying to put it into a format that has y on the left-hand side. I'm going to do some very similar things to it. All right? And what I'm going to do, and if you remember yesterday, we had some problems that had an a variable that made it a little more difficult for us to solve. So we're going to factor out a 2 from these first two terms. We're again going to sort of force the issue, force this to be a perfect square and x squared. So if I just factor these two and just factor the 2 out, because I want to keep the x squared, there's an x in common in both, but I want to keep the x squared so I can have my perfect square. So I'll be left with 2 times, and in parentheses, x squared minus 6x, and then I just keep the plus 25. All right, if I was completing the square, I would move that 25 over to the other side of the equation, and if you want to, if it helps you, go ahead and do that. But we're going to leave it for the time being on the right-hand side, and what I've done, you can see here in this next step, y equals 2 times x squared minus 6x, I've left a little blank here where I can put the number that makes x squared minus 6x plus c equal to a perfect square. And you can see I've still got the plus 25 out here. Well, b over 2 squared would be 6 over 2 squared, which would be 3 squared, which is 9. So I plug the 9 right there. Now, notice that this 9 is inside a set of parentheses, and outside of that set of parentheses would be a 2. So really what I've added right here is positive 18. Well, I'm not dealing with two sides of the equation here, so I'm not going to add 18 to the other side. Or I could, but then when I move it back to the right-hand side, it's going to become a minus 18 on the right-hand side. So I add a positive 18 here, and I'm still on the same side, so I subtract an 18 out here. Well, x squared minus 6x plus 9 factors to be x minus 3 squared. I still have the 2 out front. That's my a value. And the a value really tells us only how wide or thin it is. X minus 3 squared, and then 25 plus 8 minus 18 gives us this plus 7 right here. Well, there it sits. There's my h and my k. It's the 3 and the 7. So the negative sign there came in the equation, so we leave that there, and the vertex is at 3, 7. You remember the axis of symmetry, way back when we graphed quadratic equations, the axis of symmetry had to go through the x-coordinate of the vertex. So the axis of symmetry would have to be at x equals 3. And since a is positive, it means it's going to open up, and the vertex, therefore, would be the minimum that's at the very bottom of the graph. Here's another example. Y equals negative 4x squared plus 16x minus 11. We definitely know now that the y-intercept is 0, negative 11. And now I'm going to factor out a negative 4 so I can make this x squared part of a perfect square trinomial. So I factor the negative 4 out. That leaves me with negative 4 times x squared minus 4x. Negative 4 times, and in parentheses, x squared minus 4x minus 11. The b over 2 squared would be 4 over 2 squared, which is 2 squared, which is 4. So I add a 4 right there, and that negative 4 times 4 is negative 16. So really I'm adding right there, I'm adding a negative 16. And to counteract that, since I'm on the same side, I'm going to add 16. X squared minus 4x plus 4 factors to be x minus 2 squared. Negative 4 comes down, there's my factorization, and negative 11 plus 16 is 5. This is in vertex form. My negative 2 and my 5, actually just my 2 and my 5 are my h and my k. The 2 and the 5 are my h and my k, and therefore the vertex is 2, 5. The axis of symmetry will run through that point right there. And since this is negative, it means that it opens down, and the vertex is a maximum. It's the highest point on the graph. And last example, y equals negative 6x squared minus 24x minus 25 goes through the point 0, negative 25. That's its y-intercept. I factor out the negative 6, so that gives me negative 6 times, and in parentheses, x squared plus 4x. Minus 25. So y equals negative 6 times x squared plus 4x. B over 2 squared is 4. So I'm adding negative 24 here. So I got to add positive 24 right here to counteract. That means when I factor this, x squared plus 4x plus 4, I get negative 6 times x plus 2 squared minus 1, and that means my vertex is at negative 2, negative 1. The axis of symmetry goes through x equals negative 2, and it opens down. This is a maximum point.